Okay, let's dive right into this explainer. Today, we're unpacking a highly concentrated concept that is absolutely defining the future of development. I mean, if you've spent any time trying to stitch an LLM into a traditional tech stack, you know the historical nightmare we've been dealing with, right? You end up duct taping all these disparate tools together, battling latency, and wrestling with massive context windows, basically just to get a simple prototype off the ground. Well, our source material today points to a massive paradigm shift, one that directly tackles this pain point and radically changes how we create software.
So, what does it take to build a full-stack AI app from scratch? That question is going to frame our entire journey today as we break down the actual mechanics of modern software creation. Because building an AI app from scratch is fundamentally more complex than just throwing together a traditional CRUD application. We're not just moving text from a database to a user's screen anymore. You're dealing with non-deterministic outputs, heavy prompt orchestration, token streaming, and massive embedding models. It's a huge architectural lift. But don't worry, we are going to distill it down to its absolute core components.
And here we're looking at the three foundational pillars: the front end, the back end, and the database. Now, you already know these pillars, for sure. But what's really critical to understand from our source is how integrating AI creates totally unique bottlenecks across every single one of them. Think about it. The front end suddenly needs to handle real-time server-sent events for streaming tokens. The back end? It's no longer just a simple router. It has to be this robust agent tech orchestration engine. And the database must evolve way beyond simple rows and columns to handle complex, high-dimensional semantic space. Trying to balance these three in an AI context is usually where development just grinds to a halt.
So let's jump straight into Section 1, Building from Scratch. When our source text specifically mentions building from scratch, it implies a very raw starting point. We're talking absolute zero. Think about the immediate architectural paralysis developers face when staring at a blank canvas in an AI context. Before you even write a single line of business logic, you're forced into this labyrinth of decisions, like which framework handles LLM state best? How are you going to implement retrieval-augmented generation? What's your caching strategy so you don't rack up massive API bills? Starting from scratch historically meant spending weeks just building the scaffolding before you ever even hit the actual AI use case.
Achieving this build requires navigating a logical, chronological sequence. We go step 1, the front end, step 2, the back end, step 3, the database, and finally, step 4, one workflow. But let's be totally honest about the friction between those first 3 steps. The traditional slog involves painstakingly wiring a client-side interface to a middleware server, then configuring connections to a persistent storage layer, and then somehow injecting your language model logic into that brittle pipeline. It's super disjointed. But, that struggle is exactly what builds the anticipation for step 4, the one workflow. That's the ultimate goal engineering teams are desperately trying to reach. But let's look a bit closer at the individual hurdles first.
Moving on to Section 2, the front-end experience, the bridge to the user.
So the front end is our ultimate bridge to the user. But in an AI app, the demands placed on this presentation layer are entirely different. We aren't just talking about rendering static HTML or basic forms anymore, right? We're talking about building dynamic, highly responsive chat interfaces capable of handling continuous data streams. Your front end needs to instantly parse markdown streams from an LLM in real time. It has to seamlessly manage typing indicators, handle interruptible generations, and gracefully mask the inherent latency of large language models. It's the very first critical ingredient. If that streaming experience isn't flawless, the entire illusion of the AI app just completely collapses.
Next up is Section 3, Backend and Database Core. Let's look at those hidden layers.
Now, the backend really does the heavy lifting here. It acts as the brain and engine of the application. But an AI backend is way more than a simple API gateway. Our source material really highlights how this layer has to operate as an advanced orchestration engine entirely out of sight from the user. This is where you're aggressively managing context windows to make sure you don't drop crucial conversational history. It's where you're executing complex tool calling routines, routing prompts to specialized models, enforcing rate limits, and caching those expensive LLM responses. Basically, the backend is managing a highly unpredictable layer of intelligence and forcing it into a structured, reliable application flow.
Working hand in hand with that backend is the database, and storing application data for AI requires a totally different approach to memory. You can't just rely on standard relational tables anymore. We are literally talking about the absolute necessity of vector databases and robust document stores. To power anything like retrieval-augmented generation, your database must securely store, organize, and query complex vector embeddings.
It acts as the essential memory bank, pulling highly relevant semantic context from vast datasets and seamlessly retrieving it the exact millisecond the orchestration backend asks for it. Without this specialized storage, your AI app basically has zero long-term memory or contextual awareness.
So, the crucial point to take away here is understanding the historical friction between that visible user interaction on the front end and the hidden logic and storage on the back end and database. Historically, connecting these two sides has been incredibly painful. You're constantly dealing with this impedance mismatch. Developers have spent countless hours defining complex GraphQL or REST endpoints simply to pass a streaming LLM response from the database layer all the way up to the client. Writing all that glue code, formatting the data payloads, maintaining separate typings across the stack, that is exactly what slows development cycles to an absolute crawl. It is a massive, massive bottleneck.
Which brings us to Section 4, the one workflow revolution, unifying the stack.
Managing these distinct systems used to be deeply fragmented, but our source material reveals a huge shift towards one workflow. And this is a real game changer. It's the absolute unification of these historically complex, disparate layers into a single, elegant process. What does this actually mean in practice? The total obliteration of boilerplate code. We're talking about erasing the need to constantly context switch between 3 different terminal windows, or manage separate hosting environments, or write brittle glue code just to get your vector store talking to your front-end components. This unified approach takes development cycles that literally used to span weeks and condenses them down into literal seconds.
The source gives us this exact quote: "Frontend plus backend plus database in one workflow." It perfectly distills how modern AI apps are being built today with unprecedented efficiency. Think about the massive implications of this mental model shift for a second. When you aren't drowning in the plumbing and infrastructure setup, your cognitive load frees up entirely. You can finally focus 100% of your energy on the actual AI behavior, prompt engineering, and the unique product value you're delivering to the user. You no longer have to juggle disparate environments, they are seamlessly fused together, and your velocity for shipping features just skyrockets as a result.
The magnitude of this shift becomes incredibly clear when you look at this contrast. In the past, the fragmented approach required you to maintain completely separate mental models. You had to navigate a microservices hell, dealing with disjointed typings and constant deployment friction across the front end, back end, and database. Now, the AI app approach combines all of this into one unified workflow. You get end-to-end type safety. You get a single deployment command. It radically simplifies the entire development cycle, stripping away all that historical friction and actually enabling solo developers to build enterprise-grade AI architectures that previously would have required an entire team of specialized engineers.
Let's synthesize all of this into our core thesis. Creating full-stack AI apps built entirely from scratch no longer has to be an exercise in frustration. By fully incorporating the front-end, back-end, and database into a single paradigm, massive technical complexity has been streamlined into one cohesive system. And this matters because it fundamentally democratizes AI app creation. Going from a totally blank canvas to a fully orchestrated, production-ready application with vector storage and streaming front ends is now a highly accessible, integrated process. The barrier to entry hasn't just been lowered, it has completely collapsed.
As we wrap up this explainer, I really want to challenge you to rethink your current development habits. Stop spending your time writing boilerplate glue code and wrestling with fragmented systems because honestly, the underlying infrastructure is essentially a solved problem now. With the front end, back end, and database fully unified into a single, streamlined process, the real question is, what will you build in this one workflow?